Welcome everyone to another Datalere webinar. Today we're very fortunate to talk about a very interesting topic that is of concern to a lot of different practitioners out there. How to blend Snowflake and Databricks in a single environment. And we have fortunate to have Mark Goodwin from Janus Henderson Investments to talk about how they're doing it at their company. So a little bit about Datalere provides modern and comprehensive data solutions to both commercial and nonprofit organizations of all sizes, helping clients turn data into their most powerful assets and stay one step ahead of the competition. My company, Eckerson Group, recently joined forces with Datalere to provide end-to-end consulting services from strategy all the way to development and deployment. Very happy to be on board. These are some of our recent consulting clients. If you have any interest in working with us, either on strategy, governance, architecture, design, implementation, deployment, just give us a call. My name is Wayne Eckerson. I'm strategic consultant at Datalere. And with us today are Michael Spiesbach, manager of data architecture and engineering at Datalere, and Mark Goodwin, data architect at Janus Henderson Investments. Michael, do you want to say a few words about your background? And then Mark, you can follow.
Yeah, thanks, Wade. I'm Mike Spiesbach. I'm the manager of data architecture and engineering here at Datalere. And over the last 5.5 years, I've designed and implemented over 20 data solutions, including AI and ML to data lakehouses and traditional data warehouses. Many of the solutions that I have implemented have been either Databricks or Snowflake, and sometimes both. So I'm excited to talk with everyone today about what it looks like to blend these two into the same environment.
Thanks, Mike. My name is Mark Goodwin. I am a data architect at Janus Henderson Investments, and I've been with the company over 20 years. I started back in August of 2000, but then in the middle of that time, I left to do some consulting, then returned back to Janus Henderson. And I've been in Databricks and Snowflake since 2000 when I came back to Janus Henderson. And my passion is data. I've had a lot of different roles. I've been a data architect, product owner, solution architect as well, but it's always gone back to data. So excited to talk to you about it today.
Terrific. Thanks, guys. So with that, I'm going to turn this over to Mike, who can talk about what you're going to talk about and then start talking about it.
Thanks, Wayne. Yeah, so before we dive into what it looks like to blend the two products together, I think it's important that we cover, the strengths and weaknesses and how each of these products are designed and architected by Snowflake and Databricks so that we can truly understand their strengths, weaknesses, and the reasons why we want to blend them into one environment. They're both very similar in these products now, like a Snowflake and a Databricks. The more mature that they get, the closer they are getting in terms of features and functionality. But Wayne has actually said this to me in the past that the closer that these products converge, their strengths still remain their heritage. And that's kind of what we want to cover today. And, make sure that everybody understands what Snowflake is good at, what Databricks is good at, and why it does make sense in some use cases to combine them in the same environment. And, say Snowflake and Databricks, they're very popular, and more with the clients that we've worked at from the previous slide that Wayne had showed. A lot of them are moving to this hybrid environment where they have Snowflake and Databricks and they're using them for their strengths. And so we want to make sure to cover all of that for everybody today and make sure everybody's on board with Snowflake and Databricks in a hybrid environment, and then cover a successful use case at Janus Henderson and make sure that, we let everybody know that this is possible, and it is a very good way to establish a data architecture and a data platform in your organization.
So I'm going to cover the Databricks architecture. This picture, there's a couple of things to note here. One is on your Databricks account, you'll see that they've broken it up into a couple of different planes here. So there's the control plane, as indicated here. That is where the users actually interact with the Databricks user interface. So the web application, that's where you write your notebooks, your ETL code is in that control plane. It's also where you set up your jobs and your data pipelines. you orchestrate them there. And then also any queries that you run happens in that control plane. They also have a command line interface that you can also install locally. So there's also that way to do that and interact with the system. Also is the compute plane. So the compute is, the virtual machines that actually run, the code and the ETL code and the machine learning and et cetera. There's a couple of different things there. The classic compute, which is up on the right side of the diagram, that is, what traditionally Databricks started with, and that is where the virtual machines are being provisioned in your own cloud account. So whether it's AWS or Azure or Google, they're being provisioned there and in your account. But there's also the serverless option, which is on the bottom under your Databricks account there in the picture. That is where, Databricks is managing those VMs, and they kind of maintain what's called a warm pool of virtual machines. So you're not needing to provision them in your own cloud account. So that's kind of a high level explanation of Databricks and the components here.
Terrific. Just want to remind the audience that if you do have questions or comments or thoughts, put them in the Q&A section and we'll bring you into the conversation. So let's move to the next slide.
Yeah, so now talking through Snowflake. Snowflake is a cloud native data platform designed for warehousing, analytics, and data sharing. And it's really known for its performance, scalability, and simplicity. Mark mentioned that the historical way of using Databricks was using compute in your own cloud account, and there's some administration and configuration that you're required to do in order to use that. And so on the Snowflake side, they've really gone towards the simplicity of having a full SaaS-based data platform to where you can go on their website, even right now, sign up for an account. You don't have to even have an Azure AWS or GCP account. You can go in and sign up, and your compute's there, your storage is there. It's all managed by Snowflake. So Snowflake's architecture, similar to Databricks, is kind of broken up by these three different areas: the services layer, the query processing, or the compute layer, and the storage layer. So I'll kind of work my way from the bottom up. So the storage layer is stored in a centralized cloud storage environment. So customers can use their own cloud storage in their own cloud account, which would be, blob storage or a data lake or S3. And Snowflake can query that as an external stage, is the terminology in Snowflake. But if you're just using Snowflake as a SaaS product, what Snowflake does offer is they store your data in their own cloud storage buckets using a proprietary file format. And then from there, the compute layer is where we have these virtual machines, these clusters of machines that are used to query your data, process your data, and execute code. The difference between Databricks and Snowflake, and this is kind of where the products are now converging, is with Snowflake, these are completely virtual. We don't know where they exist, but they are these clusters that are in that warm state or even in a hot state, to where cluster spin up time is essentially negligible, and you don't even notice that these clusters are spinning up when you execute a query for when the clusters are shut down. And another thing with the clusters in Snowflake is that they can run independently, or they can also run in parallel. And so you can use multiple clusters to process data and execute code. And then the cloud services, that's kind of Snowflake's bread and butter, where they manage all of this for you, where we don't have to do anything from an administration perspective to spin up a warehouse. You can click a button on the UI and get a new warehouse or a new cluster that you can use immediately. This is also where like the query optimizer, the metadata manager, and all of the access controls and security are on. And in this architecture diagram, there are things that are missing. Snowflake is constantly releasing new products, and there are things that fit into this architecture that don't necessarily have a specific call out in this diagram that they offer. So recently, they've introduced an ETL tool called OpenFlow, which is based off of Apache NiFi that can run inside of your own cloud environment, and it kind of adds that drag and drop ETL functionality to it. They've developed their own proprietary LLMs called Arctic. You can host applications in Snowflake. They have a comprehensive data marketplace for sharing data between different users within your organization or purchasing or subscribing to data externally, as well as AI and ML features that kind of fit in and use these virtual warehouses for their processing. So we wanted to do a little bit of a comparison, kind of give a nod to one of the two platforms for what they're good at. And so this first item is unstructured data. Since Databricks is very good at using cloud storage for how it accesses data, Databricks has the nod over Snowflake when processing unstructured data, and that could be images, videos, other types of files that might need complex processing to make them usable inside of a reporting environment. And so Databricks gets the nod there, but because of Snowflake's query engine and their optimizer and their proprietary storage method, Snowflake is definitely much better at processing the structured data than Databricks is. From an ETL perspective, due to the nature of the notebook-based coding environment that Databricks offers and the different languages that are supported and the CI/CD types of capabilities that you can utilize in Databricks, it's definitely a stronger ETL tool from the complete scope of everything you need to do from ingestion to transformation, as well as machine learning. I think Databricks giving you the ability to configure your clusters and your compute enables you to do some really impressive machine learning training inside of the Databricks environment, whereas Snowflake, because you don't have control over the compute, it's more difficult to control the clusters and the compute that you want to train on your machine learning model. And within Databricks too, you can do the deep learning and utilize GPUs, whereas in Snowflake, that's not a feature they have available yet. We gave the nod to Snowflake from the AI perspective. I think Cortex Analyst and Snowflake Intelligence are the two things that really put it over the edge over Databricks. The Cortex Analyst and Cortex Search Service, allowing you to create the semantic models inside of Snowflake, which is kind of a metadata layer where you build the semantics about your data so the AI and LLMs that are interacting with your data can get as much context and as much knowledge from you, so they're more accurate and less prone to hallucinations than other environments where that semantic model does not have, where there isn't that semantic model capability.
I think on the AI, I could even slide it over into the middle because I think they're really close. In a lot of these cases, they're really tight. I mean, they're truly trying to beat each other. So, that AI is a tough one for me. We gave it to Snowflake, but it's almost a toss-up for me.
Yeah, and I think as these two products converge in functionality, they're both going to have very similar offerings in all of these different categories. And so I think this kind of highlights the heritage too of both of these products, is that Databricks really is, their heritage is unstructured data processing using Python or Scala to process data in a very distributed format, where Snowflake really is that SaaS database offering that has evolved into something a little bit closer to Databricks and vice versa from Databricks to Snowflake. And so, yeah, just to touch on the last couple of bullet points that we have here, serverless compute. Snowflake has always been serverless. It's only been serverless and having these virtual warehouses. And I think that's a nod to Snowflake's heritage. Databricks has only recently introduced the serverless compute concept within the last year and a half. And while it is good, there's still a little bit of work that Databricks needs to do to match the true serverless nature of Snowflake. And then I'll cover data sharing on the Snowflake side. And Mark, if you have any other comments you want to add or talk about streaming in Databricks. But on the data sharing side, I think with the capabilities that the data marketplace in Snowflake offers, it allows you to purchase or subscribe to data from data providers all around the world. If you're in the travel business and you want to get airline data to try to predict revenues, maybe there's events happening near some of your properties. Well, the Snowflake marketplace has airline data out there. They have weather data. They have all sorts of data where you can subscribe to it, and not only the marketplace, but their data sharing capabilities. We had worked with a client this past year that instead of pulling data from a source database from one of their vendors had recently offered them a Snowflake data share, and so now instead of having to pay the money for ingestion and use another product to get data into Snowflake, they're subscribing to it in Snowflake, and that data is available in their system without any ETL or any additional code.
Yeah, I mean, I think on the streaming side, Databricks is continuing to make strides there, and they have a product called Autoloader that they just released. With it, they're highlighting more and more, which is just gives you this ability to just use SQL to point at a file location, and it handles the management of the streaming data coming in a cloud location, for example. So yeah, I mean, I would agree. I think they have the ease of use covered there over Snowflake.
So, guys, as you can imagine, we've had a few questions come in. So, let's see what we've got. So, from Hussein saying, in Snowflake, Snowpark allows allocation of virtual warehouses with GPU and other extended memory. I guess that's a comment. So, Snowflake is leveraging GPUs at this point. I think, Mike, you said only Databricks was.
Yeah, in Snowflake, it's a very new feature to allow the use of GPUs, and it's much farther behind what Databricks has. From the perspective of you can provision your own compute in your own cloud environment, whereas with Snowflake, that's still, you don't have as much control. And if you need a large array of GPUs, say for deep learning inside of the Snowpark environment, that's a little bit more difficult to do than in the Databricks environment. Was kind of the point I wanted to make there.
Great. Another question was, are you making ETL synonymous with ELT? And if that's the case, are you still giving the nod to Databricks for ELT and ETL?
Yes. Yeah. I think in the context of both Snowflake and Databricks, ELT, ETL they're kind of synonymous, especially in these very powerful cloud data platforms. And as these products grow too, they're going to have all of these offerings. They're going to have ETL and ELT solutions. But yes, we are using them synonymously, and I would still give the nod to Databricks. Part of that is also because of that autoloader feature that Mark had mentioned, is that they also have ways of ingestion that are not just querying data from external storage.
So my question is, from what you've seen, how are both products, what are the major changes they've made to be more like the other? Because when they started out, Snowflake was really for data warehousing and data warehousing people, and Databricks is really more for data scientists and that kind of a workload. And we know they're fiercely competitive now, and they're trying to match each other's features and functions. But what have you seen where they've made the biggest strides in each case?
Yeah, so I think from the Snowflake perspective, when Snowflake first started, we couldn't even write stored procedures in SQL. And so from there, it has evolved into Snowpark. And so the notebook-based type of development that Databricks had offered, Snowflake did not have that when it was first conceived. And so now it's giving you the flexibility to write code in Python and do that notebook-based development and scheduling that Databricks kind of built their foundation on. And then from the Databricks perspective, it's the serverless compute. One of the problems that on the next slide, we're going to talk through some of the difficulties with each of these platforms is using Databricks for your traditional data warehouse was a lot more difficult. And there was a lot of performance impacts, say with refreshing dashboards, waiting for cluster spin up time and things like that, that now that they have the serverless offering, that's a much more compelling reason to do some of your data warehousing inside of Databricks than it was historically.
One more question, this one from Ronaldo. It's my understanding that Snowflake allows you to control your warehouse scaling from a script. Can you be more specific on how this was difficult? Does that make sense?
Yeah. Yeah. So controlling, I think maybe I misspoke, but I think there's less control that you have over your compute in Databricks or in Snowflake than in Databricks. You can, uh, for example, auto scale with a simple alter warehouse command. But there's much less customization from a compute perspective in Snowflake than Databricks.
Okay, great. All right, that's all the questions for now. So why don't we move to the next slide? The challenges.
Yeah, so I think we covered a lot of these in the last slide and just kind of wanted to highlight some of the challenges of working with both and where we still see a little bit of room for improvement from Snowflake and Databricks. I did just harp on Snowflake taking the nod in the serverless compute, but serverless compute can also be a detriment. You want to have control of your compute in certain use cases, and you want to have that complete configuration ability to, install different libraries, for example. And sometimes in Snowpark, there are limitations on Python libraries that you can install. And in Databricks, there isn't that constraint. And maybe there is from an organizational perspective, but you can pip install pretty much any library in Databricks, whereas in Snowflake, that's a little bit more difficult. Also in Snowflake, there is a little bit of limitation on query optimization control. I don't know if anybody on the call has looked at a Snowflake query plan, but it's a lot different than a traditional relational database explain plan or query plan. And so if you're an expert in SQL Server at tuning queries, it's a lot different and a lot more difficult to get the detailed information on queries that you can in traditional relational databases. I'll cover Snowflake, and then Mark, if you want to talk through Databricks, so I'll continue on. The next one is proprietary SQL, and so Snowflake was originally based off of Postgres, and I can't remember the version. It was I don't know, in maybe 8.6 or something. Don't quote me on that. But as Snowflake has evolved, some of their SQL has diverted from traditional Postgres, things like qualify, flatten, and some of the streams. So it's going to kind of lock you into the vendor. It's going to be harder and harder to get away from Snowflake. So I think this title maybe should be vendor lock-in. But yeah, they're starting to diverge from Postgres, adding more and more functionality. That's great in Snowflake, but kind of locks you into having to use their platform if you're using that type of functionality. And maybe this is an old slide because there are instances where you can do GPU acceleration, but historically Snowflake has been behind on the GPU utilization. And now that they've started to introduce more LLMs, that's becoming more widely available. But designing deep learning, deep learning neural networks, that's a little bit more difficult to do in the Snowflake environment and has been historically. And now as these products converge, kind of how we've been talking, it's getting easier and easier, and that functionality is starting to roll out from the Snowflake side of things. And then lastly is the unstructured data. I think that's where Databricks really excels, and Snowflake is getting there, and they're starting to add some AI around unstructured data or semi-structured data searching, but it definitely lacks compared to Databricks.
Yeah, on the Databricks side, Spark overhead, I think that's a little bit like taking a sledgehammer sometimes to put a tack in the wall. You've got all this power, and a lot of times you don't need it. So there's a lot of Spark overhead, unnecessary overhead for some of these small workloads that a lot of us have. The complex cluster configuration, I think serverless makes it very simple. The management's out of your hands. You don't really need to worry about it. You just kind of point at it and say go and run your code. I think sometimes, managing that, takes a lot of time, and, sometimes there's a lot of frustration sometimes that the clusters take a long time to come up as well. So, there's some downsides to that. Yeah, the fragmented governance security, they've done better with Unity Catalog. I think they're making a lot of headway there, but I think, previously it was lacking that fine-grained control, the lineage, etc. But they're starting to get better, I think, on the governance side and the security. So that's a little bit of a challenge, but also, there's some improvements there they're looking at. I mean, it is heavily notebook centric, and which, I mean, I like to work in notebooks preferably, but it doesn't sort of lend itself to this reuse of code and sharing of code. I think you have to be really purposeful about that and in doing it. So I think that's, maybe one of the downsides of that. And then on the dependency management side, I think maybe Mike, you want to talk to this one. I'm not up to speed on that one.
Yeah, I think the point on this one was that developers can't necessarily develop in their own kind of local virtual environment like you would if you were developing an application on your machine, and that
Mm,
there can be a challenge managing environmental consistency across clusters if there's a need for it. And so that was kind of the point to make, is that it's hard to apply, say, if you have an entire team of engineers working on or needing specific environment configurations on a cluster, then what do you do about the job cluster? It's more configuration, or if you need multiple clusters for the developers with the same configuration, it's a little bit more difficult to manage um, than it can be. And I think Databricks is also working on that as well to kind of make that environmental consistency easier to configure.
One question has come in. Do you have comments on cataloging governance and security in Snowflake?
Yeah, I think Snowflake is trying to roll out more governance features. I think if you look in Snowsight, their UI, they do have a governance tab, but there's not a whole lot that they offer natively in the platform. So I think we could apply that governance to both Snowflake and Databricks. They are actively working on it by continuously adding features under their governance abilities. But I think to have a strong governance program in place in Snowflake, a third-party product is probably our recommendation, to have that fine-grained governance over everything inside of the data platform. And I think that still goes with Databricks, but as these products evolve, they're definitely adding more and more governance capabilities and things like lineage and stuff like that.
Great. Let's move on to the next.
Yeah, so kind of getting into the topic of the webinar after talking through Snowflake and Databricks a bit. Why do you need both, or what use cases does it make sense to have both inside of your environment? Right, both of these products do a lot of the same things very, very well. But I like to think of it as that quote at the bottom: Databricks is where you build intelligence, and Snowflake is where you operationalize it. And so let's think of the strengths of Databricks for a second, and we'll kind of talk through what the overall architecture looks like here in a little bit. But Databricks is really, really a powerful ETL, ELT engine. Snowflake is as well, but it's better at structured data. So if you have a lot of unstructured data or a lot of machine learning and advanced modeling and forecasting that you need to do on your data, Databricks is definitely the environment to do that. And from there, we can transfer that data into Snowflake so it's readily available, easily accessed into your reporting tools. And so that's kind of the thought process behind this. And this was done historically by organizations that were struggling with Databricks cluster spin up time for reporting, or having real-time reports or direct query in Power BI, having to have those clusters always running, where in Snowflake, you don't have to have them always up and running. They can spin up very, very quickly. And so typically customers and clients that we've worked with have done most of their transformations and the heavy workloads that Databricks can really thrive in supporting. And then using Snowflake for their gold or their reporting layer so that there's no latency issues with refreshes on their reports. And so kind of the personas that would use the different platforms when we have this hybrid environment. So data scientists and engineers would primarily be using Databricks, writing code, and doing those heavy transformations, the machine learning, data cleansing, and things like that. And then once that data has been cleansed and refined and essentially gotten into that silver conformed state, then the data would be ingested into Snowflake into dimensional models that are built for reporting. So we're using the reporting performance of Snowflake and the powerful ETL, ELT capabilities of Databricks, as well as the unstructured data processing capabilities in Databricks to kind of take advantage of the strengths of both in this one cohesive environment. And Mark, I don't know if you have any other comments or thoughts, but I'm curious as to some of the considerations that you all made at Janus Henderson when adopting the hybrid Databricks Snowflake environment.
Yeah, I mean, I think you said it. It's that last statement that Databricks is where you build intelligence, Snowflake's where you operationalize it. I mean, that was our consideration. It was that instant on compute that we needed from that the hot compute, as you said, with Snowflake that we needed. You know, if you're going to put a BI tool on top of your data and give it to your users, they're not going to want to wait. Um, 3 minutes for a compute cluster to come up. Even 1 minute, they won't wait. So they need that data right away. And that was initially why we had brought both pieces in because of their strengths, right? As you talked about, Databricks was strong on the transformation side and the analytics side, and then on the data warehousing side, it was definitely Snowflake. So the structured data side, anyway. That's really what our consideration is. But I think now you're starting to see that as they're both starting to copy each other. You're starting to see the lines blur a little bit. And so I think there's definitely some considerations you can make to your architecture given that.
Do you guys see a time where it might make sense to just go with one platform? Or do you think that it's hard to tell, right? But the differences will always be there to some extent.
I think in the real world scenario, yes, it'd be nice, but then on the other hand, it's like you got all this sort of historical stuff you've got to move over to the platform. So you got to consider that. That's why it's tough for companies to move over to one after you get so much invested in both platforms. I guess it would take for me to take in the case of a large project, for example, at Janus Henderson, that might be a consideration where we say, hey, we really need to standardize. We need more efficient. We need people in one platform. I think there's some efficiencies there, but you're always going to have this sort of you're going to be giving up something, right? Because I think like Snowflake and Databricks, they have their strengths and areas. So it'd be tough for me to say, going to one platform, but. No, that's my opinion. I don't know what do you think, Mike.
I think in the scenario where you do not have a footprint in the cloud and are not using one of these platforms, I think there's an argument to where one or the other might make sense, especially as they're converging in features. And I definitely think with the introduction of the serverless compute for Databricks, it's much more compelling for maybe Databricks as your platform when 3 years ago Snowflake made a lot more sense. But I think I don't see a reason for existing organizations that are using both to migrate to one or the other. But if you're starting out from scratch and your plan is to only have one, at this point in time, it really there isn't a huge difference between features and functionality. So either one, I think, would allow you to be successful in your BI platform or your analytics platform.
Of course, having a hybrid environment also keeps the vendors honest, right? And the CFO likes being able to play one off against another to get the best deal. So that's another consideration. All right, so we got a ton of questions coming in now. We'll take a few of these. So Magnus asks, for ELT, ETL, are these platforms good enough, or can there be situations where you might want to use third-party tools like Informatica, DBT, or Ab initio?
What do
Mark,
you
I
want
don't
to
know
say?
if you want to answer. I
I
have a
mean, I'll
couple
just
thoughts.
say that I think, these WYSIWYG environments, like Informatica, Matillion, etc., where you're really dragging, dropping components. I think, yeah, those can be helpful. I think though, on the Databricks side, for example, and even Snowflake is trying to do this. They're trying to build more visual capabilities in their platform. So, for example, in Databricks, Lakeflow, it's called Lakeflow Declarative Pipelines that they've come out recently and released. They're really moving towards, having natural language control your ETL. So it's the way I see these platforms going is for ETL is English is the new programming language, and you really go in, and you basically type in what you want, and it builds the ETL for you. I know that sounds a little far-fetched, but that's where they're headed. And I think a developer will still need to be managing that, but I think you can do a lot with natural language. I think here in the next 1 to 2 years, you're going to see a lot of things happen there. And so, yeah. I think these platforms are going to be really are going to be adequate for that ETL. I don't know, Mike. What do you think is happening there?
Yeah, I definitely think from the once the data is in the platform, both are working on tools and technologies internally that enable that drag and drop ETL type of processing, ELT, ETL. Um, I still think both are lacking from an ingestion perspective. Snowflake has OpenFlow, they have Snowpipe, Databricks has autoloader, but compared to vendors and products where their sole purpose is ingesting data like a Fivetran or a Rivery or even an Azure Data Factory or Matillion or things like that, I still think there's a place for them in these platforms or in these architectures, at least for now. But once Snowflake and Databricks start developing really, really comprehensive ingestion capabilities, then I think they can be their own self-contained architecture and platform.
Kind of not all or nothing. It's never all or nothing, is it? You kind of
Yeah.
use a mix of stuff.
Okay, we have a bunch more questions, but I think you may address some of these in the subsequent slides, and we only have 15 minutes left. So let's move ahead and we'll make sure we circle back to some of these questions that are queued up.
Okay, great. So just wanted to touch on kind of the conceptual and physical architectures of the medallion architecture. And I'm sure some of you who have been on these webinars in the past may have seen Carlos Bossi and Wayne talk through this slide before. But this is kind of a traditional zone-based architecture where we've now converted it into what the medallion architecture looks like. And there's a lot of boxes and a lot of arrows and things like that. But from a high level, the medallion architecture really is a layer-based or zone-based architecture where quality and refinement progresses throughout the different zones. So we have our raw data or our data that we've ingested from our source systems, and it's really inherits the data model from the source systems. There's no modeling or anything. It's typically organized well, so it's easy to use and not a lot of cleansing or transformation. And really the only thing we typically do is add timestamps to it so we know when data has been ingested. And then that kind of transforms the data as refined from the raw zone or the bronze layer to the silver, which is really the conformed zone. And that's where data is integrated, it is cleansed, it's deduped, data quality checks are put on it, it's filtered, it's transformed, joined, whatever you want to call it, so that it's in a state where now we can start to build our dimensional models or model the data in a way that it's easy to be consumed, which would then be our gold layer. So this is really a conceptual view of this architecture. And each of these different zones, bronze, silver, gold, or raw, refined, formatted, analytic zone, those are not, those are product agnostic, essentially location agnostic. So our raw and our raw or bronze and our silver can be done in Databricks, and then we can move the data into Snowflake and then have our analytics or a gold zone be in Snowflake. So it's easy to be consumed by BI and reporting tools. And that's kind of the traditional way that blending the two environments together has gone. And so I wanted to just give a quick conceptual view of what a complete data architecture looks like with the medallion architecture. And then Wayne, if you want to go to the next slide, we can quickly take a look at what the closer to a physical implementation of this would look like. So we have our source data kind of flowing in. We have customers, transactions, accounts, and in our bronze. And so that's going to be exactly as it is in the source system. And then that data is going to be processed, transformed, cleansed, filtered to a cleansed customer table, so our customer master, and then our cleanse or transaction or sales master type of table. And then that'll be combined in the silver layer to be our master customer transactions table. And we'll use all three of those different silver tables to build a customer sales data mart, for example, in the gold layer that's then consumed by users either through Power BI or whatever reporting tool or way of reporting that organizations typically consume their data. And so this is how the data would flow throughout that medallion architecture as it's progressively cleansed and transformed so it is consumable by the users. And blending these two environments, what we typically see is that bronze and silver are Databricks. We leverage the Databricks processing engine and the notebook and transformation capabilities that Databricks offers. And then we leverage the structured data, very powerful query engine that Snowflake has for that BI or reporting zone or gold zone. And so if you want to flip one more slide, I'm trying to go quick to make sure we get through all of this. Here's a very high level view of what it would look like to blend the two environments and a little bit of how the data would flow. So we all have our raw data, we have our CRM data, our ERP data, our applications, and also files, and it can be structured, unstructured data coming from all of those sources. In this instance, kind of going back to the last question, because of all of these different sources that organizations are pulling data from now, Databricks and Snowflake don't support the comprehensive ingestion capabilities of a 5-tran Rivery data factory Airbyte. And so we want to leverage another tool. And I believe at Janus Henderson, Mark, correct me if I'm wrong, you guys are using Azure Data Factory for some of your ingestion that can't be done through Databricks. And then that raw data is stored in a data lake where we kind of take it from there in Databricks. So from there, we're building our bronze and silver layers. We're transforming the data. We're getting it into the Delta Lake format. We are processing it, joining it together, creating these master data sets of, customer master, transaction master, sales master, things like that. And then from there, we want to leverage the capabilities that Snowflake offers from the structured data perspective. So then we use our silver data as our source for our dimensional models, our reference data, master data, things like that. And then we have our dimensional models gold layer built inside of Snowflake, which is then consumed by users. Mark, anything else you wanted to call out on this slide before we move on to how things actually look at Janus?
No, I think you covered it pretty good. I think you're going to find my diagram looks a lot similar to this one, only with a lot more blocks on it, I guess.
All right, let's see what it looks like.
Yeah, so this is kind of current state, or I'd say, I almost called it yesterday's state because it's constantly evolving, but this is kind of what we started out with, which was it's kind of moves from left to right as Mike was showing in his diagram. And you've got a mix of on-prem data sources, APIs, files in your blob storage, and then also Data Factory, pulling data from Salesforce into your data lake and Databricks, and then, creating those refined data sets. And then because of that need to operationalize it, we would then push it to Snowflake and, you know, serve it up in one of many different tools, right? Whether it be Power BI, we have users that use Alteryx as well. And we have, obviously Databricks, we need to access the data again from Databricks at times, to use their dashboarding capabilities, Tableau, and then, API layer in Azure is also accessing that data from Snowflake, and all because of that sort of operational aspect. Yeah, so I mean, this kind of covers that the current state right now, but the next slide can kind of tell you where we're going with the future. And what I see happening is, I think with the open format, for example, with Iceberg, where both it's an open storage format, table format that is Apache Iceberg, and both platforms are starting to embrace it. And I think what should happen here is that if you really think carefully about how you store that data, if you use Iceberg, open format like Iceberg, you can, basically have the data interoperable between the two platforms, and you can actually interact with it in Snowflake or interact it within Databricks. It really doesn't matter. I would call it, bring your own compute. So, you have the storage. It's all in your Azure or AWS or Google, whichever you've chosen. But then, which platform you want to use to actually transform the data, or do machine learning, or do dashboarding or analytics, you can use either platform for that. And so, you can see in this picture that, I've got data coming in from the left, which is, some on-prem databases, APIs, and files, etc. But then on the right, we've also got things like files coming through Snowpipe into Snowflake. So it kind of illustrates this environment that, depending upon what you need in each platform, you can load the data, and then if it's stored in that, that open format of Iceberg, it's queryable and usable at both platforms. I think that's what we're trying to get to. And, you know, we could go down the route of one platform, but I think, we're pretty well invested in both. So for us, doesn't make sense at this time. So I think this is probably the best kind of middle ground, that we can find.
So there were a few questions on the data transfer. And one person wanted to know what you're using today and if the data is duplicated between the platforms.
Yeah, we're trying to get away from that. I mean, we did previously, we kind of, that was what we had to do. We did have to duplicate the data between the two. But now, they're starting to play nicer with each other. So they're able to actually, Snowflake can look at an external source and Databricks can look at an external source. So you really don't have to copy the data any longer. You just have to really configure it properly, and then also obviously test the performance, make sure that it performs well. But I think in a lot of cases, that copying data around isn't necessary as much as it used to be. Do you agree with that, Micah?
Yeah, I think so for sure. And it's interesting that you bring your own compute. It's almost like bring your own storage and bring your own data and use either one at any time. And I definitely think that's the direction that Snowflake is going for sure, is that they're going to be pushing that bring your own storage, and which Databricks has had for quite some time. And so maybe the direction that both of these are going is you're storing your data, maybe it's Iceberg, maybe it's some other format internally in your own cloud environment, and then you can use their query engines to query it. It feels like maybe that's what you meant for bring your own compute. But yeah, I definitely think that bring your own storage, bring your own data, and then put these two powerful engines on top of it. One for what Databricks is good at and one for what Snowflake is good at is definitely the direction that things are headed.
So this question might refer to the current state environment more, but what about the data transfer performance as well as egress and ingress costs between the two platforms? With unstructured data, especially, was the context.
I don't know that I have a good sense for. I've done a lot of studying of the Databricks costs, but on the Snowflake side, it's a little. Have found it a little harder to get at. I don't know if Mike, you have any thoughts on that.
Yeah, I don't have a ton of thoughts on that, but I will agree that the Snowflake cost is a little bit more difficult to drill down and see. Let's see. I think maybe reframing the question as, are there any challenges you see to using these two environments as you currently are when it comes to data transfer between the two, or anything you would do differently or want to change moving forward that kind of gets away from that high level architecture that I showed?
Yeah, I mean, I don't know if there's anything new past what what I've t discussed already. I think just taking advantage of, some of I mean, the serverless piece on the Databricks side is, I will just say it's a big cost savings for those of us who've been using traditional compute on the Databricks side because you no longer have to pay for that virtual machine on the Azure side. Basically almost your costs are being cut in half in a way. So I can't say it's definitively half, but it's pretty close. So you no longer have to pay that Azure cost as well. You're just paying the Databricks cost. So from that perspective, it's very visible to see the cost savings. So moving to all your workloads to serverless, that's probably the biggest thing that I would change when it comes to Databricks, and also taking advantage of you know, the new features of Databricks that, for autoloader and things that make maintenance a lot easier because I think, maintaining sort of the code around, loading files and having to decide, oh, I'm looking for a file. Is that file still there, etc. There's a lot of features in Unity Catalog that make that a lot easier. So I think from that ingest standpoint, we're just trying to take advantage of all those new pieces. And so we're kind of going through a conversion right now of a lot of our notebooks to try to simplify them. So I think simplification is what we're aiming for. And that's going to drive costs down.
Yep, definitely.
Well, guys, this has generated a ton of questions. We would have to go for another half an hour or more to answer them all. Great questions, great comments. I thank everyone in the audience for those. I think we will put together a round two of this in the not too distant future so that we can get at some of these great questions. So at that, I'd like to thank the audience for your attention and for your insights and commentary and questions. But most especially, Mike and Mark, thank you for putting this together and sharing your insights and thoughts on the topic.
Yeah, thanks for the opportunity. Great to be here.
Yeah, thanks, Wayne.
Have a great rest of your day, everybody.
Have a good one.
Thanks.